So in this video, we're going to go over the 3B CFA review, okay? So let's jump right in. So it says, given the following right triangles, solve for the missing side lengths, round to the nearest degree. So what I like to do here, always just label the sides first. So obviously the side opposite the right angle is the hypotenuse, right? And in this case, it doesn't matter which one of these is A or B. So this is going to actually be our C, right? Because it's our hypotenuse. And I want to say this is A and this is going to be B. And we're going to use our equation, A squared plus B squared equals C squared. And that's because we have two sides and we're trying to find the third. So we're going to say 4 squared plus 7 squared equals x squared. So that's going to be 16 plus 49 equals x squared. 16 plus 49 is 65. That's equal to x squared. And remember, we're going to take the square root of both sides here. So you're going to do second x squared in your calculator. So for this problem, x is going to be equal to 8.06. It doesn't tell us to give it in simplest radical form here. It just tells us to round to the nearest hundredth, okay? So for this next one, same thing. We're going to label what we have. So this is now our hypotenuse, which is going to be our C, right? And so this is going to be, these are going to be A and B. So I'm going to say this is A and this is B, okay? So as we work through our formula, we're going to do 5 squared plus x squared is equal to 12 squared. So it's going to be 25 plus x squared equals 144. We're going to subtract the 25 from both sides. So that's going to give us x squared is equal to 119. And so again, we're going to take the square root of both sides. So on our calculator, second x squared, that's the square root. So it says the nearest 100th here, okay? So we're going to, again, do 2 decimal places. 10.91 is our answer. So that's our answer for that one. This is our answer for our first one. The next one says, given the following right triangles, solve for the missing side lengths, round to the nearest degree. Or hundredth, sorry again. So the very first thing you want to do here is recognize what you have. So I notice that I have a 45-degree angle here, which means this has to be 45 because those two have to add up to be 90. That means this is going to be an isosceles right triangle. These sides are going to be congruent. Those angles are going to be congruent. So we have one formula for a 45, 45, 90, and it says h is equal to the leg times the square root of 2. And these are our legs. And our hypotenuse, again, is across from the right angle, right? Okay, so we're going to solve for our legs because x and y are going to be equal, right? So we're going to say that this 6 is equal to, and we're going to substitute the x in, and we know that x and y are going to be equal. The square root times the square root of 2. To get rid of that square root of 2, we have to divide both sides by the square root of 2. And then we can't have a radical in the denominator. But in this case, it's telling us to round to the nearest hundredth. But I'm going to go ahead and do this just so we can do both, okay? So I'm going to, just to remind you guys, this would be the square root of 2 over the square root of 2, right? We don't have to do this because it says round to the nearest hundredth, so we could actually just do 6 divided by the square root of 2 to get the answer. But I'm going to do this just to remind you guys how to do it. So this is going to be 6 square root of 2 over the square root of 4, and that's going to be 6 square root of 2 over 2. So our answer is going to be 3. Remember, these can simplify, right? So that's going to be 3 square root of 2. And you can just calculate that in your calculator. And what I want you guys to see is that whether I do this and find x, or I do this and find x, I'm going to get the same answer, okay? So it says round to the nearest hundredth. That's 2 decimal places. So this is going to be 4.24, okay? All right, so our next one, again, says given. So this is a 30, 60, 90. I hope all of y'all can see that. So that means this is my hypotenuse. This is my short leg because it's opposite the 30-degree angle. This is my long leg because it's opposite the 60-degree angle. Our formula for hypotenuse is h is equal to 2 times the short leg, right? And our short leg is y. So we're going to say 10 is equal to 2 times y. Divide both sides by 2. So now we know y is equal to 5, okay? So I'm going to put up here that this is equal to 5, and that's also our short leg, right? So to find our long leg, if you remember, the long leg is equal to the short leg times the square root of 3. The way I keep that straight, the square root of 2 and the square root of 3, is that 30, 60, 90 has 3 angles, so the square root of 3 is attached to the 30, 60, 90. So this time we got x here is equal to, and that's 5 times the square root of 3. So our two answers here are y is equal to 5 and x is equal to 5 square root of 3. And this was our answer here for both x and y, right? Because they're both the same, because they're both legs. All right, so our next one said, given the following right triangle, solve for the missing side length. Now remember, when we have ratios and we have side lengths, we're trying to find side lengths. We're just going to use sine, cosine, and tangent. When we're trying to find an angle, we're going to use an inverse. So again, let's go ahead and label what we have. This is going to be our hypotenuse, right? And how is this side? It is attached to that angle. So this is our adjacent, okay? So what ratio uses A and H? It's going to be cosine. So this is going to be the cosine of 25 is equal to the 13 adjacent over the hypotenuse, which is x. Now remember, these swap places, the x and the cosine of 25. So x is going to be equal to 13 divided by the cosine of 25. Put that in your calculator. And again, it's telling us to round to the nearest hundredth. So when we do that, we got, what did I get? You know what? Let's go back, because I was supposed to get that other answer in the hundredth, y'all. So give me 1 second. 5 square root of 3. But this one is going to be 14.34. Okay, so let's go back to that previous one, because I never gave you that. This answer right here, y'all, it says into the nearest hundredth. So I'm going to multiply 5 times, 5 times the square root of 3. And that would have been 8.66. So this x is going to be equal to 8.66. Okay, that's the real answer. Okay? So once again, we're going to label our sides. So this is equal to h, and this is now the opposite, right? So what ratio uses opposite and hypotenuse? That's sine. So we're going to do the sine of 69 is equal to the opposite, which is x, over the hypotenuse, which is 10. Now remember, to get rid of that 10 in the denominator, we're going to multiply both sides by 10, right? So we can put this, so then we have that x is equal to 10 times the sine of 69. You can actually put this in the calculator just like this, 10 sine 69. And when you do, that's going to tell you that x is equal to 9.34. Okay? All right, so our next one is, okay, let's go ahead and label these sides. So this is our hypotenuse, right? Now, relative to that angle, this is adjacent and this is opposite, right? So that's our tangent, right? The 13 and the x. So we're going to say the tangent of 36 is equal to opposite over adjacent. Once again, the x and the tan 36 switch places. So x is going to be equal to 13 divided by the tan of 36. And that means x is going to be equal to 17.89. There we go. I was trying to find my paper. All right, so then we have our next three. So this time we're looking for angles, y'all. So if we're looking for angles, we're going to use inverses. So we're going to do second sine, second cosine, second tangent based on the. So again, we're going to label things. So we're going to say this is going to be h, right? And this is going to be adjacent. Yeah, so what ratio uses adjacent and hypotenuse? That's cosine. So we're going to do the inverse cosine. Whoops, the inverse cosine of 4 over 8. Put that right in your calculator, and that's going to give you the measure of our angle. So our angle is going to be equal to 60 degrees. And this says round to the nearest hundredth. Again, that's 2 decimal places. So on this next one, again, we're going to label what we have. This is our opposite, and this is our adjacent. What ratio is opposite and adjacent? That's tangent, right? So we're going to do the inverse tangent again because we're looking for an angle. So it's going to be 41 over 44. Put that in your calculator. So our angle here is going to be 43 degrees. All right, last one. So again, let's label relative to that angle. So that's opposite, right? And this is hypotenuse. What ratio uses opposite and hypotenuse? That would be sine. So we're doing the inverse sine of 27 over 30. Put that right in your calculator again. And this time, we actually do get an angle that we need to give the 2 decimal places for, 64.16. All right, our next three problems are word problems. So it says a cable supports a 15-foot telephone pole. So we got a 15-foot telephone pole, and it's perpendicular to the ground. So that means our ground is here, right? And it says if the cable forms a 60-degree angle to the ground, so here's our cable, right? And that means this is going to be 60 degrees right there, okay? So, and it says, how far is it from where the cable connects to the ground to the telephone pole? So how far is from here to here? That's what we're going to solve for, right? So once again, this would be our hypotenuse. This is our opposite, and this is our adjacent. Now, there's another way we can do this, right? Because this is a 30, 60, 90 triangle. Do y'all see this? Okay. So that means we can use our formulas for 30, 60, 90 as well, which means this would also be our short leg, and this would be our long leg. So it doesn't matter which way you do this. I'm going to show you both, okay? So if I use the ratio, it would be opposite over adjacent, right? So that's going to be the tangent if we use the ratio. So we're going to do the tangent of 60 is going to be equal to 10 over x, right? Opposite over adjacent. So here again, we swap those. So x is going to be equal to 10 divided by the tangent of 60. So when I did that, I got 5.77. So x is equal to 5.77. Okay. Now, the other way to do this is our 30, 60, 90 triangle, right? So we could do it that way as well. So we know that the long leg is equal to the short leg times the square root of 3, right? So if we have the long leg, so that's going to be 15, and we're looking for our short leg, that's x, square root of 3. So we can just divide both of these by the square root of 3. 15 divided by the square root of 3, you can actually put that right in your calculator and guess what that is. It's still 5.77. And again, these are going to be feet, okay? So it doesn't matter which way you do it, one or the other, okay? So then this next one says, what is the estimate of the length of point A to point D? Okay, so this one, so it's asking for an estimate from here to here. I'm assuming that's D up there. So estimate means we're just going to use the information we have. So our 28 degrees is there. If we go straight across to there, it's asking us for a value in here, right? And so let's talk again about that. Would be the right angle would be there. So this would be our hypotenuse. This is going to be our opposite, and this is going to be our adjacent, right? So we have the adjacent, and we want the opposite. So we're going to do the tan. So we're going to do the tangent of 28, and that's going to be equal to the opposite over the adjacent. Now remember, when we have a number in the denominator, we got to multiply both sides by it to get rid of it. So x is going to be equal to the 3 times the tangent of 28. And again, you can put this right in the calculator just that way, and it's going to give you 1.6 feet. Okay? All right, this last one says, given the following image, at what angle is the tower leaning? Okay, so again, this is asking us for this angle down here, right? So remember, we're going to use an inverse if we're looking for angles. So that's a right angle right there. Let me move this out of the way. So that means this is our hypotenuse, right? And this down here would be our adjacent. So what ratio uses adjacent and hypotenuse? That would be cosine. Now remember, we're doing an inverse cosine because we're actually looking for the angle. So the adjacent was 17 and the hypotenuse was 179. So we're just, again, putting this right in the calculator. It's doing all the work for us. And this says, when we do that, we get 84.6 degrees.